Okay, hello students. I hope that you are excited to, discuss another topic under gravitation, that is Archimedes principle and buoyancy. So this will clear a lot of concept of yours, that how or why does some object, float and others do sink. Okay, so let's discuss. So first of all, whenever you're putting an object, okay, in water, either it will float or it will sink or it remains suspended. Okay, that means it won't float with the water, it won't sink, but it will be suspended like this in water. Water is floating, it is suspended. Okay, so this behavior is determined by the buoyant force. Okay, now this phenomenon was actually explained by the Greek mathematician. So mathematician was the one who came up with the idea of buoyancy. Okay, that is Archimedes. Now, what exactly buoyancy is? It is the upward force exerted by a fluid on an object immersed in it, opposing the weight of the object. So what happens? Suppose if this is, water. Okay, so the water will apply some upward force to the object which is immersed by it. So just to imagine that if you have ever gone into a swimming pool, or if you have gone, underwater sometimes, maybe near beaches or something, so you will feel a push time to time, right? So that push is there because buoyancy is there. The upward force exerted by a fluid on the object immersed in it, opposing the weight of the object. So your weight is pulling you down, pushing you down, right? But the force applied by the liquid is pushing you up. Okay, so this is opposite to gravity. Buoyant force always pushes things upward, okay, acting in the opposite direction of the gravity. So on earth, if you are this is water, okay, so earth will pull you down, but the water will push you up. Okay, so it is always in opposition to gravity, you can say. Depends on three factors. Now, buoyancy depends on what factors, how it is decided that something will float or sink. Okay, so let's first take a plastic bottle floats while an iron ball sinks. Why does it happen in water? Because of the difference of density, relative to the water. Now, what do we mean by that? We'll see. So three things on which actually the buoyancy depends is density of the fluid, that how dense the fluid is, volume of the fluid displaced, that how much volume of the fluid is being displaced by the object. So if an object is lying here, so this much water is being replaced, right, from this exact position. Okay, and acceleration due to gravity. Right, so we'll see these things one by one. Okay, before that, so Archimedes principle, what it states is that when a body is fully or partially immersed in a liquid, okay, so if body is there, it is immersed in liquid, maybe fully or maybe partially. So if one, side is like this of a starfish, let's say, so it experiences upward buoyant force equal to the weight of the fluid displaced by the body. Okay, can be sound, a lot to take, but okay, let's figure it out one by one. So if a body is immersed, okay, in a fluid, let's say this is fluid, this is your ball. Okay, and let's make water with blue color. Okay, so it experiences a force, upward force on this object. Okay, now that how much that force is, it is equal to the weight of the liquid displaced. That means the weight of the body itself, because body will displace how much water, howsoever weight it is carrying, the object is carrying, displaced by the body. Okay, so how much space or weight of the fluid it will displace, that much force would be applied to push it forward. Okay, now the formula here would be FB, that is a buoyant force, right, is equal to rho GB into, everything is in multiplication. Okay, so buoyant force, rho is what? Density of the fluid. Okay, how much dense it is, like we already discussed, right? On three things the buoyant force depends. First one is the density. If the density is more, the force would be more. Okay, the buoyant force would be more. If the density is less, the buoyant force will be less, because it is directly proportional. Okay, now acceleration due to gravity. If acceleration is more, then because it is equal and opposite, right? So it will be more. And if we talk about the volume of the fluid displaced, so how much, if I am putting it in water, okay, in water, I have kept it. So how much ever space it is taking, not space, how much weight of water it is displacing, moving ahead, or, letting the water scatter so that it can take the place of that water. So that much weight of water, if we, take it, so then we will be able to calculate the buoyant force. Okay. Now, when objects float, sink, or suspend, the relation between an object's weight and buoyant force determines its behavior. So, how an object, sinks? Let's talk about that first. 1 second. Right. Now, object sinks when the weight is more than the buoyant force. That means what happens? The buoyant force is not enough to keep that something, upward. So the downward force the downward pull of the gravity overcomes the upward pull of the buoyant or push of the buoyancy, and that's why things fall. Because suppose if this is more, I'm giving you just an example, or this is not the exact value. This is +1. Okay. Sorry, +2. But this is only +1. Okay. So this will end up pulling it down. Okay. The gravity will end up pulling things down inside the water. But if the buoyancy is enough, equal, okay, so it will, or more, so it will actually float. If the buoyancy is more than this, than the gravity, then it will float. And if the buoyancy is just equal, first I was going to discuss equal, then I just changed. Okay. So if it is equal, then that object will be suspended and won't move much. Okay. So object floats when the weight is less than the weight of the object, you can say, or the weight of the water which has been moved or displaced by the object is less than the buoyant force. Then the buoyant force exceeds the gravity and starts pushing the object upward until equilibrium. Okay, so it lets the object float. And I told you, when the weight and buoyant forces are equal, the forces balance perfectly, causing the object to hover, like on that place only hover. Okay. Right. So applications would be ships and submarines. Okay. Hollow ships, because you might have seen that in ships, or in Titanic movie, or in a lot of, ship movies, you might have seen this space is actually hollow. Okay. So that the weight of the ship is not more. Okay. So hollow ship hulls displace enough water to create a buoyant force that is greater than their weight, and that's why they can do such thing. Submarines adjust buoyancy by changing their volume using basalt tanks. Okay, so that's there. And hydrometers. So these are nothing but some sort of instruments which used to measure the fluid density. Okay, so there also it can be used, and it decides, or it observes that how deeply they sink in different liquids floating higher in denser fluid. Okay. So these are hydrometer. Again, this will I'll explain later. Okay. And hot air balloons. So heating air inside the balloon decreases its density a lot, creating the buoyancy in the surrounding cooler, denser air. So any fluid, this buoyancy can be there. Okay. So it will let the hot air balloon move upward because the density became less. Okay. So it will move up. Now, you have seen buoyancy at work when the logs float downstreams, or when you float more easily in a salt water than a fresh water. So you might have seen that in salty water, you can easily float, but in fresh water, you are unable to. So that is also because of the buoyancy and the density of the water, you can say. Okay, now this is the numerical which you will be solving. Let me just quickly, hide the calculations for you. Now you will try to solve it. Okay, what you will do is, a solid cube of volume 0.002 meter per cube is completely immersed in water. Find the buoyant force acting on it. So you have the volume. Okay, volume is given to you. So, and density of the water is also you are provided with. Okay, now acceleration, you already know it is 9.8. Once you will put everything under your formula, which you already know about, that how buoyancy, the buoyant force is dependent on what things it is dependent on. So it will be, you can say the rho would be around 1000 okay, into 9.8 and into 0.002. So this will come around as 19, you can say, 19.6. Yeah, it's 19.6 Newton. Okay, so that will be your answer. Okay, this is numerical too. This you can try solving by yourself. Okay, so maybe if you want to take a screenshot, you can take screenshot, or simply you can just, write the question. Don't look at the solution. I have given it so that you can check it later. Okay, so just take a screenshot, go over the question, try solving it. A wooden block of density 600 kg per meter cube floats on water. Okay, density, what is the density of water? 1000, it's given 1000 kg per meter cube. What fraction of its volume is submerged? Okay, so here you have to use a little bit of brain. Okay, and if you have any doubt in this part, you can ask me. Okay, now, yeah, let's come to the Eureka moment. Okay, what happened here? A story time. Okay, so the king Hieron, too. Okay, he asked actually Archimedes to determine if his crown was made up of pure gold or not. Okay, or if the goldsmith has substituted it with some of the silver. Okay, so while taking bath, Archimedes noticed that the water level rose when he got in. He suddenly realized that the volume of the water displaced is equal to the volume of the body submerged. This I have already told you, right? So this could be used to measure the volume of irregularly shaped object. Okay, that how much volume does it have? Okay, combined with the weight, he could calculate density and determine if the crown was pure gold or not. So he was so excited that he reportedly, ran naked through the streets and shouting, Eureka, Eureka. Eureka means basically, I found it, I have got it. Okay, I have discovered it. So he was happy. So this was just a that's how he realized that how we can calculate actually the volume of the water displaced and volume of the object actually. Okay, so again, I have given you the answers here. Sometimes I'm trying to do that so that you don't have to worry about. You can just try these questions and check whether your concepts are clear or not. Okay, so buoyant forces acts in which direction? Downward, upward, sideways. So it is upwards, which is completely opposite to the gravity. When does an object float? When the weight is more than the buoyant force, when the weight is equal to buoyant force, or when the weight is less than buoyant force? Obviously, when the buoyant force would be more, it will push the object, upwards, and that's how it will float. Which instrument works on Archimedes principle? So, barometer, hydrometer, thermometer. This again in depth, I will explain you what exactly hydrometer is in the class, okay? Right? So, thank you so much for joining the session. Okay. If you have any doubts related to, physics, chemistry, or biology, or specifically this topic, you can ask me on my Urban Pro profile. Okay. Take care. Have fun. Bye-bye.